So year 8, we are talking about adaptations. This is Astra. Obviously, most of you have met my dog by now. And she is obviously a greyhound. Greyhounds are built for speed. So top greyhounds can run at about 40 miles per hour, which is faster than a car, so she'd get done for a speed camera. She could probably run at about 30 mile an hour, as you've seen in the other video. So what we're looking at is how is she adapted to run that fast? So obviously we can see here these massive muscles on her leg. Obviously look at how thin she is. This again is so that she's got a really light body frame so she can run at speed. If you look at these really long legs here, tiny thin legs, look, this is just a tiny bit of skin here. Again, this is all built for speed. She has very, very light bones, very slight skeleton, and as you can see, she's actually very aerodynamic. So actually her head is not any really bigger than her neck, which is why if you look, we can actually take her collar off without hurting her because her head is so tiny. So if you look at other dogs, so if you've got a dog at home, have a look at your dog and see how she is different from Astra.
Girl. Okay. All right, and we've talked about Astra, but some of you also might know Mr. Deaton's dog. This is Daphne, and Daphne is a miniature schnauzer. Now, miniature schnauzers were bred for a couple of jobs. Astra wants to get in on the treat here. Miniature schnauzers were bred for a couple of jobs, one of which is being a ratter. And if we have a look at Daphne's physical adaptations here, she's quite little and she's sturdy, which means she'd be very, very good at getting into small spaces and hunting out rats. So she was bred to be a ratter and potentially also used to herd geese. Now, not just physical adaptations, but behavioural adaptations as well. How does she behave? Daphne has a very, very high prey drive, so that means she really, really wants to chase things. She's very good as a watchdog, so she will bark if she sees something, and she will chase something very easily. That's why she's really, really good at doing the jobs that she's bred to do. So that's Daphne. Okay, and year 8, your job now is to list the similarities that we can see between Astra and between Daphne, because we've talked about differences, but now your job is to see what have they got that's similar. We are going to give them both a treat for being so excellent, and that is going to give you a clue. What is our last topic? What might we not be able to see in these dogs, but what's internal that might be the same for these guys? Me? Good girl. Astra. Nicely. Good girl. All right.
Okay, year 8. So again, carrying on with our adaptations here, we have 2 types of insects. So in this one, we have a grasshopper. So I'm just going to get this out to show you. So, as you can see, they hop.
Blooper reel, Miss Moore is not keen on the grasshoppers.
So we put that one back in there. And then here we have a locust. This one, I'm actually going to hold it this way. This one has actually got wings. You can probably see. Unfortunately, it's lost a leg.
Oh.
So what happens is, as you can see, it's got really tight grip on my finger. So you can see the wings there very clearly. I'm going to put him back in. Now what you may not know is that a grasshopper will eventually become a locust. So grasshoppers hop around. When they run out of food, they will not actually make a chrysalis like a caterpillar, but they will basically go somewhere quiet. Their outer shell goes quite hard, and then eventually they will emerge from this into this. So basically they go from a hopping insect into a flying insect. This means they are able then to fly off to find different food or a mate or just travel to another area. So this is left behind as the shell or the exoskeleton of this original animal. So now this is Maud. This is a tropical Pac-Man frog. So she lives in hot, tropical, wet conditions. And unfortunately for Larry the Locust,
Circle of life.
he is going to become her dinner. So he's actually only got one leg, as you can see, so actually he wouldn't survive in the wild anyway. So we're going to see if Maud will...
Oh. It's Maud feeling peckish.
Sometimes it takes her a little while to twig. But there's dinner. She's getting ready. See, she's inflating her body. Now
She's
looking.
seen it. Where's Larry?
There you go. So she's very, very quick when she wants to be. So she's very, very slow most of the time to reserve her energy. So she's got a slow metabolism. But when there is food around, as you saw, she pumps up her body, gets ready, and then her strike for the prey is actually very, very quick. And this meal will last her around about a week.
I would imagine, miss, and tell me if I'm wrong, that the markings on Maud, that if she was kind of buried in like a dried up bit of mud or something, she'd be quite hard to see. Is that right?
Absolutely. Does anyone know what the name of that is? It's actually camouflage. So I want you to find out, how do you spell camouflage? A bit of research for you there. So beautiful colourings there. We are not allowed to actually touch Maud. She has very, very sensitive skin, and if you touch her skin you can actually cause burns on her body. So there's Maud.
Right, now for challenge year 8, who can see what we've got in this enclosure. Can you spot him? Over here. This is one of the stick insects, and I'm sure you guys can guess what their adaptation is. Clues in the name. They are stick insects, and that guy was alright. He was sitting on top of the leaves, so we could spot him. But their adaptations are to look as stick-like as possible, and they conserve their energy by staying very, very still, so that they don't need to use that energy to move around. And when they're still, they are camouflaged even better, because things like birds, who might be their predators, are going to spot them if they move, but if they stay really nice and still, we've woken this one up here. You can see how much it looks like a stick or a twig. If they stay still on those branches, they are really, really tricky to see. And that's how they are so well adapted
They also
to
have
not getting eaten.
tiny hooks on the bottom of each foot to actually cling onto the leaves.
Right, we've spotted here as well that we've got a baby stick insect who has just hatched. The thing you can see on its foot there is its egg. It's still attached to the egg. It's just coming out of it. And see if we can get a size comparison here. Where's my finger? Teeny tiny baby stick insect there, just coming out of its egg.
Okay, so here we have Andrew. This is a giant African land snail. So you can see we've took him out of his enclosure, and you might have noticed then this coming out. This is one of his eyes. So when he's frightened, he will put them away and they retract inside for safety. You've also got at the bottom here these tiny tentacles. So that's an adaptation for feeling around his environment. Unlike us, he doesn't have a skeleton on the inside, and he doesn't have feet, although he has one big foot here, and he produces a mucus so he can obviously slide along. So these here are eyes, bright on the end, and you'll be interested to know that Andrew has no ears. So Andrew is actually deaf.
Oh.
Although he can feel vibrations. So instead of normal hearing like us, he can hear vibrations coming through the ground, through his skin and through his foot. You'll obviously see here, if I touch Andrew, he will normally retract all the way into his giant shell. So this, very hard. Andrew is only still a baby. He will get quite a bit bigger than this. So if I turn him around, you can obviously see this beautiful shell. It's made of calcium carbonate. So we do have to feed Andrew cuttlefish rather, and that will give him the calcium to make this big shell, which will get bigger and bigger as he gets bigger.
So is it right, Miss, that he won't change out of his shell? He will grow his shell as he grows.
Which is why he would have obviously started off at this end, very small, and then he builds up what we call, I think it's called a whorl, and that will just get bigger and bigger. Andrew is also a hermaphrodite, so he has male and female body parts. Although they do still reproduce sexually with other snails, they can actually, in difficult times, actually reproduce on their own. So I'm hoping as Andrew or Andy is on her own, that one day she will have his own or her own offspring.